Hello class, and welcome to lesson 7.5 arithmetic series. Don't worry, ladies and gentlemen, if you've wondered why we skipped a couple lessons in terms of the lesson numbers. These just match up to our textbooks. We're just skipping a couple lessons or sections in the textbook, so don't worry about that. You haven't missed any lessons. All right, so today we're dealing with series, okay? We're going to be dealing with arithmetic series today, and we're going to be dealing with geometric series next day. Now, the one thing we got to do is series is different than sequences. So series have plus signs in between the numbers, okay? So you're going to see plus signs as opposed to commas. Okay, so let's just back up, guys. The definition here, I should highlight. Let's get a highlighter out. If we can highlight. Perfect. Okay, so an arithmetic series is the sum. That's the key thing to remember here, guys, of the terms in an arithmetic sequence. Okay? So we're going to add all the terms up. Let's take a look at the examples and what's the difference, okay? So for example A, first of all, I see commas, so I know that it's a sequence. Arithmetic, I got to check, hey, what's happening each time, guys? Hopefully you know that you're adding 3 in each case. Because you're adding 3, that means that D equals 3. We know that it's a sequence because we have commas. B, ladies and gentlemen, is taking a look at the same set of numbers, but notice that it's a series because we have plus signs. We want to know the total sum. So your answers are going to be a lot bigger than what you used to see before. And how do we know that it's a series? Because we have plus signs. Okay? So in both these situations, guys, if we asked for A equals 2, it's the first number, and D is the same in both cases, D equals 3. But we have to deal with how we get the sum of this versus the sequence or the number. The best way I can explain to it is pretend you work at a grocery store, ladies and gentlemen, and the boss asks you to make a pyramid of cans, okay? You could start with 1 on the top, then maybe 3 on the next, and then keep going in a nice symmetrical pattern down to build this pyramid of cans. If we are taking a look at the arithmetic sequence, that will tell you, hey, how many cans are on just the bottom row, or the 10th row, or the 2nd row, or the 5th row. Whereas arithmetic series says how many cans total in your pyramid. That's the biggest difference, okay? Because it's the total, which means it's the sum. Okay? If you're curious as to how we got the formula, ladies and gentlemen, or the proof for it, it's on page 449. However, you can peruse that if you like. It's not necessary as long as you just understand that how to sub the information into the formula. So here is the formula. And remember, the formula is the sum. Sorry, give me a second. Okay. The formula is the sum of the first n numbers or n terms of an arithmetic sequence is given by. Okay, so what's different, and you'll notice the difference in the formula is it's S at n, which means the sum of the number, of all the numbers, as opposed to T, which was your term number. Okay, and in both these cases, you notice there's 2 formulas, ladies and gentlemen. The first one is when you're given A and D, which is what we've experienced before. This second one is used when you're given the first and the last term, okay? So you're given A and the last term is given. Okay, so that's when you use that one specifically. All right, let's take a look. This is a short lesson today, ladies and gentlemen. We're just going to do a couple examples, and then you'll be on your way. Okay, example 1. Find the sum, so we have to know we're using S at n, of the first 40 terms, so that means n equals 40, in the series. So first of all, look at the series. 18 is our first number in our first term number, so we're going to make A equal 18. Let's take a look, ladies and gentlemen, what's happening in each case. In each case, hopefully you recognize that you're adding 4. So that tells us that D equals 4 because there's a common difference. Okay? And ladies and gentlemen, if we look which formula we're going to use, we have to use the first formula because the second formula is only used when you're given the last term. It's not given, so use the first formula. Okay? So I'm just going to write it out first, then we'll sub in our information, and we'll solve. All right, so subbing it in, we know that instead of S at n, we're going to go S at 40, which means the sum of the first 40 terms, okay, equals n being 40 times 2 times 18 plus 40 minus 1 times 4, all divided by 2. A quick cancellation I'm going to do, ladies and gentlemen, is take 2 divided by 2 goes into 2 once, and 2 goes into 40 twice. My biggest error, ladies and gentlemen, is people, if you can't cancel out, people lose or forget about the divide by sign. Okay, so if I simplify some things through, I've got 20 times 36 plus 39 times 4. And ladies and gentlemen, just plug that all in your calculator and you should get an answer of, get your calculators out, dun dun dun, you should get 3,840. So you say, therefore, the sum, that's the difference here now, you got to write sum of the first 40 terms is 3,840. All right? You're going to expect big answers here, ladies and gentlemen, because you're summing. The only difference is next day you'll see that you could have a negative sum as well, depending on how the ratio works, okay? All right? Or you can have a negative sum, ladies and gentlemen, if your difference is getting, if your thing's getting small, if your sequence is getting smaller or your series are getting smaller. All right, example 2 says calculate the sum, be careful of that one, of the series, you can tell it's series because you got plus signs, given here. What is tricky is we're not given the n number. We don't know n. So we don't know n. What we do know, ladies and gentlemen, is, what does 5 represent, ladies and gentlemen? That's A, so A equals 5. What's happening to our patterning here, guys? Hopefully you realize that you're adding 3, so D equals 3. Okay, and what else do we know? Let's take a look at this. That's the last term. We know T at n equals 2,135. Okay. So in this case, we don't know n, but what we can do is if we know t at n, we can use the arithmetic sequence formula in order to find n, and then apply it to the series. So let's do that. So we're going to use the arithmetic sequence, there's my short form, guys, formula to get n. Once we have n, then we can sub it into the above formulas. Okay? And just remember, n, guys, is the number of terms. Okay? So from 2 classes ago or 2 lessons ago, you learned this was your arithmetic sequence formula. Okay? Sub in what we know. We know t at n equals 2,135. We know a equals 5 plus n, that's what we're trying to find. Subtract 1 times d, which is 3. So let's rearrange this formula. So we're going to have 2,135 equals 5 plus 3n minus 3. Collect like terms. Put all your constants on the left. You're going to have 2,133 equals 3n. And to get n by itself, you're going to divide by 3. Whatever you do to one side, you do to the other. So we have n equals 711. What does that tell us, ladies and gentlemen? That tells us that we have 711 terms in that series. Okay, so now that we've got the 711, now we can use it and put it into the formula. Okay, so now we can use S and N equals N, T1 plus Tn. I'm just going to use the last one because we're dealing with the N value as given. Okay, so you could have used the other formula as well, ladies and gentlemen, if you were working ahead and wanted to use that. So S at 711 equals 711 times 5 plus 2,135, all divided by 2. Again, you can plug that in your calculator, and you should get, dun dun dun, 760,770. So therefore, the sum of 711 terms, which is that series up above, is 760,770. Cool. All right, here's your homework, ladies and gentlemen. Page 452, numbers 3. For 4 to 7, you do A, C, E, etc., all the odd letters, if you want to call it that. Number 11, and give 13 a try. Have a fabulous day, guys, and see me if you need any help. Bye-bye.